Let's look at example 1 in the book. The example is given as y is equal to 3x squared plus 1 squared. And as you will see, this is the composition of two functions. And we have, we can let f to be u squared, and g is the inside function. We usually call, so this is f composed g. We usually call g as the inside function. So there's an inside function, there's an outside function u squared, and we compose them and we get this y, 3x squared plus 1 squared, okay? And here the question is, what is the derivative of y with respect to x? What we are going to do is we are going to do this stepwise. Like we have to first go, as you would see here, y depends on u first, and then u depends on x afterwards, okay? So because of that, we are going to use this chain rule. Chain rule says you have to first visit u, okay, and then from u you're going to visit x, okay? So dy du, we are going to take the derivative of y with respect to u first, and then we have an explicit expression for u in terms of x. We take the derivative of u with respect to x. So we just multiply it out. So dy du, if we apply the power rule, it is 2u. Du dx, we apply the power rule, we have put the 2 in the front. 2 times 3 is 6, 6x plus 0, so it is 6x. Here we got 2u times 6x. The answer has to be all in x's, so we have to convert everything to x. If you look at u, again, up here, u is a function of x, so instead of u, we just plug in what u is, 3x squared plus 1 times the 6x. We just distribute this over if you want, or you don't have to, actually. But what you got is the derivative of y with respect to x. So this is the chain rule we applied, okay? There's another way to do it. Let's look at the original function y is equal to 3x squared plus 1 squared. You can expand this formula. You can expand it as follows. It is 9x to the 4th. This times 2, which is 6x squared, and square of 1 is 1. So the first term is the square of 3x squared. So we have this expression. Now we can directly apply the derivative to the power rule, and you look in here, the derivative of this expression is going to be 36x cubed and 12x and 0, and it's the same result.